Today, Algebra 2, we're going over the dreaded test on rational exponents. So we'll begin this video with test A. Make sure you have test A, otherwise your answers will not coincide. And this test won't make much sense to you as far as redos go, but you can learn something, I guess, if that's the case. So let's get right into this. So numbers 1 and 2, evaluate each expression. Given that A equals -2, B equals 7, and C equals 4, solve the following expressions. So for number 1, with your calculator, because you were allowed to use one, you should have plugged in, let me lock my screen, there we go, 2 times -2, which is our A value, times 7, minus 3 times B, which is 7, times C, which is 4. I got all those values up here, which some students seem to not notice right away. If you put this in the calculator exactly like this, I like to separate all my negatives with parentheses. You should get the answer of -112. Next, number 2, 7 divided by B, which is 7, plus C, which is 4, minus -2, which is A, plus B, which is 7. If you type that into your calculator exactly the way it looks in the equation, just filling in the A, B, and C values, you should have gotten an answer of 0. So those two are pretty basic. You don't even have to really do the PEMDAS. Now let's get to the alternate expressions. So write each expression in radical form. It says squaring your final answers. That just means we wanted you to box in your answers. So that's what that meant. So everything should have a radical symbol, or basically the little square root house, in other words. So 16 to the 1/2. We have the base of 16. We have it raised to the first power taken to the square root. So you could have written it like that, or you could have just written it like this, because when you only have one thing, you don't have to have the 1 here necessarily. And a square root house, a radical symbol without a 2, is automatically assumed to be a number 2. Number 4, we have 16 to the 3/4. That means we have 16 to the 3rd power taken to the 4th root. You didn't even have to solve anything because I wanted your answer in radical form, not simplified to a single number, which some people did. If you showed me this at some point in your work, then you got credit. If you didn't and just gave me the number answer, then you did not follow instructions correctly. Number 5, 8m to the 5/3. That means 8m is going to be under our radical symbol. It's going to be taken to the 5th power with the cube root. If you put this in here with the 5, I probably would have accepted it also. So either one, as long as you had the 3, the 8, and the 5 in more or less those same positions, I gave you credit. Number 6, 10x to the -3/4. The negative symbol means we're going to have a fraction answer with a radical on the bottom. The 4 is our root. 10x is what's being cubed in this case. So that 3 can go out here. It doesn't really matter. As long as you give me the 1 over the 4, the 10, and the 3, in more or less that same order, I gave you credit. 7, 8, 9, 10 is the reverse. They give us the radical form. They want us to write it in exponential form. That means everything should be raised to some kind of power or have exponents in it. So number 7, 47, square root of 47. That means we have a single 47 in the house being taken to a square root. There's 1 in here, and with no number, it automatically means 2. Number 8, we have the fifth root of 91 squared. That means we have 91 squared to the 5th root. That was just a basic translation. We learned that week. 3xy squared, 4th root of it. So this one was missed a lot because this confused a lot of students. 3xy squared is the whole thing that we have 1 of in this whole radical symbol. So we have 1 of these to the 4th root. So this is how your answer should have looked. A lot of students want to multiply the 2 times the 1, which really wasn't necessary, and threw everything else off. It didn't multiply everything else times 1/4. So remember, whatever's in the radical symbol, you have 1 of those, unless there's parentheses on the outside telling you there's different amounts. Number 10, we have a fraction, so I know we have a negative exponent. I have it raised to the 7th power, so I have a -7. There's no number in front of my radical, so it's going to be a square root. And the thing that's in the radical symbol is what's actually being raised to that power. So 2y to the -7/2. The next two, number 11, next 4, 11, 12, 13, 14, are all using the exponent rules to simplify. So here, if you could give me a single number answer, cool, but if there's variables, you won't get to a single number answer. Your answer will have x's or y's or whatever in it. So number 11, we have 16x squared. So we should have taken to the 1/2. 16 to the 1/2 power times x squared to the 1/2 power. I split it up. 16 to the 1/2 power is the square root of 16, which is 4. X squared to the 1/2. That means we're going to take x squared, which is basically 2 over 1, times the outside exponent 1/2. That gives you 2 over 2, which is basically 1. So we're going to have x to the first, or just x. Now let's see what we have for number 12. Number 12, we're going to first divide 36 by 6, which is 6. We have the same bases on the top and bottom, but different exponents. You take the same base, which is x. You subtract the top exponent minus the bottom exponent. So we get x to the first power, which is just x. Number 13, we're first going to multiply all of our coefficients. 2 times 3 is 6, times 4 is 24. We know we're dealing with x. And when they're being multiplied, you're just going to add all the exponents. So you have x to the third, plus to the fourth, plus to the first, which is going to give you 4, 5, 6, 7, 8. A lot of students added incorrectly, and they forgot there was a 1 here. It's not 0. So make sure you add correctly next time, I suppose. Number 14, multiply our coefficients just like in the last one. 2 times 3 is 6. We know we're dealing with y. We're going to add 1/2 plus 1/3. Remember, in order to add fractions, you need a common denominator. So 6 is common. Turn a 2 to a 6, you multiply it times 3. Turn a 3 to a 6, you multiply everything times 2. 3, 6 plus 2, 6 is 5, 6. So you have 6y to the 5, 6 power as your final answer. On the back, now we're going to be solving each rational exponential equation. And we should be getting whole numbers, or number answers for this. So we're going to find out what x or n or whatever the variable actually equals. So without further ado, number 15. X, whoops, we locked my screen down. I do that quite a bit. X to the 3/2 power. We're going to go ahead and raise it to the reciprocal, which is 2/3. Whatever I do on the left side, I have to also do on the right side. So these will cancel out, and I have x by itself, which is what I want. 27 to the 2/3. That means I have 27, 2 of them. We multiply times the cube root of each one. Because there's 2 of them here, so 1, 2. The cube root would be 3. So the cube root of 27, what times itself again will give you 27. That would be 3. So you get 3 there, a 3 there. 3 times 3 is 9. Or x equals 9, if you want to get more algebraic about it. For number 16, we have, in parentheses, n minus 8 to the 3/2. I'm going to go ahead and, just like the last one, raise it to the reciprocal on both sides. So it cancels out here, and I have n minus 8 equals, I have 8 squared, which is 2 8s, 8 times 8, both taken to the third root. Bring down the left side. The cube root of 8, one number times itself a third time will give you 8. That would be 2. 2 times 2 is 4. So some number minus 8 equals 4. I have to add 8 to both sides. And I get n equals 12. Number 17, we begin the process again. X to the negative 2/3. I'll go ahead and raise it to its reciprocal, negative 3/2. That equals 1/25, also to the negative 3/2. A lot of people were able to get this first part started. They got lost in the second step on the right side. So a negative exponent means you basically make a fraction or take the reciprocal, really, to be more accurate. So the reciprocal of 1 over 25, that means to flip it upside down, is just 25 over 1, or in other words, 25. Once I've taken the reciprocal, I lose the negative sign, and it just becomes 25 to the 3/2. That means x equals 3 groups of 25 that are being multiplied. So I'll do it that way. Each one being taken to the square root. So the square root of 25 is 5. 5 times 5 is 25 times 5 is 125. So x equals 125. And number 18, we have x plus 3 to the 2/3 plus 12 equals 48. This plus 12 is outside any influence of exponents, so I must remove it in order to get all this stuff by itself with the exponent. So I'll subtract 12 from both sides, and I get x plus 3, let's see, to the 2/3, that cancels out, equals 48 minus 12, which is 36. Now you take everything to the reciprocal, 3 halves here, 3 halves here. Cancels out, and I have x plus 3. Then I have 3 groups of 36, so 36 times 36 times 36, taken to the second or square root. The square root of 36, one number times itself gives you 36, 36 times 6 times 6, which is going to be 216, I believe. Yes. So x plus 3 equals 216. I subtract 3 from both sides, and I get x equals 213. And there's your answer for number 18. The last two were just factoring. So I'm going to go ahead and look for the greatest common factor for my coefficients, which is 6 and 12. Now it's going to be a 6. 6 is the biggest number that goes into 6 and 12. So I have 6 times 1 times a squared, which is 2a's, times a b, minus 6 times 2, that's what my 12 turns into, times that single a times 2 groups of b, because I have them right there. Since I only have 2 terms, I want to take out pairs. So what can I take out a pair of? I can take out a pair of 6's, so I have 1 pair. I can take out a pair of a's from both sides, and I can take out a pair of b's from both sides. I'm left with 1a, so I can write it just like that. You can put the 1 if you want to, it's not necessary in this case, minus 2b's. And there's your solution. For number 20, I'm looking for the greatest common factor of 9, 3, and 6, and that's going to be a 3. So I have 3 times 3, which is 9, times x, plus 3 times 1, which is 3, times x, plus 3 times 2, which is 6, times x times x times x, because there's 3 of those. Now, since I have 3 terms, I need to take out trios. So what is common to all 3 bits of this equation? Well, I have a 3 here, here, and I have a 3 there. So I can take out 1, 3. Because I have 3 different terms, I have to take out trios. Now I have an x here, here, and here. So that's 1 x removed from all 3 of them. Nothing else, I'm not sure, can be removed, so I would bring down the remainder. I have a 3 and an x right here in the beginning. I have a, let's see, 3x. I have a 1 right here in the middle, a plus 1, because it's positive, so that's out now. And I have another plus sign right there. And I have a 2, and I have these x's, which make x squared. So there's your accurate form of those expressions. That is the explanation for test A. Please watch test B if you have that one. Otherwise, I hope this helped explain maybe some of the misunderstandings you have. Best of luck.